Close your eyes. You won't miss anything. Everything you need tonight is in the sound of this voice and in the quiet dark behind your eyelids. Somewhere above you, right now, the same stars that have always been there are still burning, exactly as they have for longer than there have been eyes to see them. They don't know you're listening. They don't need to. They'll go on shining whether anyone watches or not, the way they always have, the way they always will. Tonight, we're going to travel back. Not years, not centuries, further than that. Back past every war and every king, past every language that has ever been spoken, past every human being who has ever lived, back to a single point, smaller than anything you could imagine, where everything that exists began. It's a strange kind of journey, because there's nowhere to actually go. You won't need to move at all. Just lie there, warm and still, while the story moves instead, unfolding slowly around you the way weather moves across a landscape, patient and unhurried, taking exactly as long as it takes. Over the next 2 hours, we'll move slowly through that story. From the first fraction of a second of existence, through the birth of galaxies and stars, through the long, slow settling of worlds, to the small, warm one you're lying on right now. There's no test at the end of this. There's nothing to remember. If your mind drifts, or your eyes grow heavy, or you fall asleep before we even reach the stars, that's exactly how tonight is supposed to go. In fact, that's the whole point. You don't need to follow every detail. You don't need to hold on to a single name or number. Let the words wash past, the way water moves over stones, touching everything, holding on to nothing, wearing nothing down. So settle in. Let your shoulders drop, an inch at a time, until they feel heavy against whatever's beneath you. Let your jaw soften, let your breathing slow, in its own time, at its own pace. And let's begin, gently, at the very beginning of everything. It's strange to say, but the honest answer to what came before the universe is, we don't fully know. And there's something calming in that, if you let it be. Not every question needs an answer tonight. Some questions are simply large enough to rest inside, without needing to solve them. For a long time, people imagined the universe as something fixed, unchanging, the same yesterday, today, and always. The stars, fixed in place like small holes in a dark curtain, hung there once and never moved again. It felt permanent, because from a single human lifetime, even a long one, it looks that way. A human life is simply too short a window to notice a universe changing shape. But in the early 20th century, that quiet, settled picture began to shift. An astronomer named Edwin Hubble, looking through a telescope on a mountaintop in California, spent long nights studying faint, fuzzy smudges of light that other astronomers had assumed were simply clouds of gas drifting somewhere within our own galaxy. Hubble discovered they were something else entirely, whole galaxies of their own, unimaginably distant, each one containing billions of stars. And as he studied them more closely, he noticed something odd. Distant galaxies weren't just sitting still out there in the dark. Their light was stretched, shifted toward the red end of the spectrum in a way that meant only one thing. They were moving away from us. Not just a few of them. Nearly all of them. And the further away a galaxy was, the faster it seemed to be retreating, as they the whole universe were quietly, steadily pulling apart at the seams. There's only one explanation that fits that pattern. The universe itself is expanding. Space, the very fabric between galaxies, is stretching, carrying everything within it further apart. The way dots painted on the surface of a balloon spread further apart from one another as you slowly blow air into it. The galaxies themselves aren't racing away through space. Space is simply growing between them, patiently, everywhere, all at once. And if the universe is expanding now, steadily in every direction, then long ago it must have been smaller. Rewind far enough, and everything we can see, every galaxy, every star, every planet, every atom of everything that has ever existed, would have been pressed together into a single, unimaginably dense point. That's the idea we now call the Big Bang. Not an explosion happening inside space, the way a firework explodes into the air around it, scattering sparks into a sky that was already there. It was the beginning of space itself. Space being born, unfurling outward, from nothing recognizable at all. Before that moment, by our best understanding, there was no before in any way we can meaningfully picture. Time, as we experience it, may have started right along with everything else, which makes the very question, what happened before, a bit like asking what's north of the North Pole. It isn't that the answer is hidden, it's that the question may not quite fit the shape of what actually happened. It's the kind of idea that can make your mind spin if you sit with it too hard, turning it over and over, looking for a foothold. So we won't sit with it too hard tonight. It's enough to hold the shape of it loosely, the way you might hold a smooth stone in your palm, without needing to examine every grain of it. Everything once was nothing we could recognize. No stars, no space between things, no dark sky to look up into, no up or down at all. And then, in the smallest possible sliver of time, that began to change. Scientists have traced the universe's history back to just a tiny fraction of a second after that beginning. A number so small, it's easier to write than to imagine. A decimal point followed by 32 zeros, then a 1. Before that instant, our current understanding of physics simply stops working. The rules we use to describe stars and planets and falling apples, the equations that guide spacecraft and explain why rivers flow downhill, all of it breaks down completely at that scale. It's not that scientists haven't found the answer yet, the way a puzzle waits patiently for someone clever enough to solve it. It's that we may need an entirely new kind of physics, one that doesn't fully exist yet, to even ask the question properly. Some of the finest minds alive today are quietly working on exactly that. In universities and observatories scattered across this same small planet we'll return to later tonight. So rather than the very first instant, let's start our story just after it. At the moment things become knowable. The moment the fog begins to lift just enough for us to make something out. A universe. Smaller than a single atom. Hotter than anywhere that has ever existed since. Holding within it, already, every star and every world and every quiet thought that would ever be thought. About to begin the longest story there is. Breathe slowly. There's no need to hold on to any of this tightly. Just let the picture sit there, soft and enormous, somewhere behind your closed eyes, while we keep going. There's a quiet kind of comfort, too, in the not knowing itself, if you let yourself feel it, rather than resist it. Most of what fills an ordinary day, the small worries, the passing thoughts, the little unresolved questions that trail us from one hour to the next, feels urgent only because it's close, only because it's ours. Held up against a mystery this large, this old, this patient, those smaller uncertainties tend to soften, just a little, the way a bright light dims when you step back far enough from it. You don't have to solve anything tonight. You never really did. Human beings have always told stories about beginnings, long before telescopes or equations existed at all. Stories passed down around fires, carved into stone, whispered from one generation to the next. Every culture that has ever existed seems to have asked some version of the same question, in its own words, in its own language. It's a comforting thought, in its own quiet way, that the question itself is so old, so deeply human, even if the particular answer we have now, pieced together patiently from starlight and mathematics, would have sounded like nothing anyone had ever imagined before. So let's step into that first sliver of time. Not the very first instant. That one, as we said, stays hidden from us for now, tucked away behind a wall our equations can't yet see past. But the moment just after, when the universe becomes something physics can begin to describe, gently, one careful step at a time. At this point, everything that would ever exist, every atom in every star, every ounce of matter in every planet, every particle that would one day make up a single hair on your head, was packed into a space almost too small to picture. Not small like a grain of sand, smaller than that. Smaller than anything you could compare it to using ordinary objects at all. Because ordinary objects at that moment didn't yet exist to compare it to. And it was hot. Not hot in the way we understand heat, the warmth of a fire or the sun on your skin. Hotter than the center of any star that has ever burned. Hotter by factors that stop being meaningful numbers and start being simply a word for beyond anything we've ever measured. Hot enough that the ordinary rules matter follows today simply didn't apply yet. There were no atoms, no particles as we'd recognize them. Just an unimaginably dense, unimaginably hot soup of pure energy, existing in a space smaller than anything that has ever existed since. In that first tiny fraction of a second, something extraordinary happened. Space itself stretched, suddenly, violently, faster than light travels today, in an event scientists call inflation. In a sliver of time too short to even say out loud, the universe went from smaller than an atom to something you could, in principle, have held in the palm of your hand. And then, in the moments after that, it kept growing and growing, carrying everything within it. It's one of the strangest ideas in all of science, and also one of the best supported. The fingerprints of that stretching are still visible today, if you know exactly where to look for them. Faint patterns pressed permanently into the oldest light in the universe. As that first burst of expansion slowed, the universe kept cooling. And as it cooled, something new became possible. Energy began condensing into matter. This is one of the quietly beautiful ideas in all of physics. Energy and matter are, at the deepest level, the same currency, simply wearing different clothes. Einstein wrote it down as the simplest, most famous equation in all of science. One you may have seen written on a mug or a t-shirt, without ever quite feeling its weight. Energy and mass, interchangeable, two sides of a single coin. And in that first blistering moment, pure energy began converting into the most basic building blocks that would ever exist. Tiny particles called quarks and electrons flickered into being, and just as quickly, mirrored by their opposites, antimatter, which annihilated back into pure energy the instant it touched its counterpart. For a brief window, matter and antimatter existed in almost perfect balance, canceling each other out in flashes of light across the newborn universe. A fireworks show with no audience and no sky yet to watch it from. But almost isn't quite. For reasons scientists still don't fully understand, one of the genuinely open mysteries in physics. Matter had the faintest edge over its antimatter twin. For every billion pairs of matter and antimatter that destroyed each other, one lonely particle of matter was left over. Unmatched, unpaired, simply left standing when the dust settled. Just one in a billion. And that tiny imbalance is the only reason anything exists at all today. Everything you can see, touch, or become, stars, oceans, mountains, your own hands resting somewhere in the dark right now, is built from that leftover sliver. A rounding error in cosmic terms that quietly became everything. As the universe continued to cool and expand, those surviving quarks began finding each other, drawn together by forces already at work in that infant universe, forming the first protons and neutrons, the particles that would one day sit at the heart of every atom, in every star, in every living thing. This happened within the first few minutes. Not years, not centuries. Minutes. The universe built the basic ingredients for everything that would ever exist, faster than it takes to boil a kettle. You don't need to hold any of these words tightly. Let them pass through like a slow tide, rising and receding, leaving only a soft impression behind. Protons, neutrons, the first true particles of matter, drifting into being in a universe still smaller, in those first minutes, than our entire solar system is today. And in that same window, those first few minutes, something else remarkable happened. Protons and neutrons began fusing together, briefly, into the very simplest atomic nuclei. Hydrogen, then helium, and just the faintest trace of lithium. This process, called Big Bang nucleosynthesis, set the basic recipe for the universe, a recipe that has barely changed since. Even now, nearly 14 billion years later, roughly 3/4 of all the ordinary matter in existence is still hydrogen, cooked up in those first few minutes of everything. The simplest and most abundant ingredient in the whole vast kitchen of the cosmos. Then, for a long while, not much changed, at least not in any dramatic sense. The universe kept expanding, kept cooling, carrying its scattered cloud of particles outward into the growing dark, patient, slow, and utterly silent, because there was as yet no light free to travel anywhere at all. Light existed in a sense, but it was trapped, bouncing endlessly between particles too closely packed to let it escape, the way a whisper gets lost in a crowded room. We'll get to why that changed in a moment. For now, just picture it, softly behind your closed eyes, an impossibly hot, impossibly small universe, cooling as it grows, expanding into a darkness with no edges yet to speak of, carrying within it already, in some quiet, patient way, everything that would one day become you. None of this needed to happen the way it did, and yet it did, every single time, in every corner of that first newborn universe, all at once, all following the same simple, patient rules. There was no plan being followed, no hand guiding any of it towards some particular outcome. Just matter and energy and the quiet, reliable pull of physical law, working itself out, everywhere, simultaneously, the way water always finds its way downhill, without needing to be told which way is down. It can help at this point in the story to simply let the strangeness of it wash over you, rather than trying to hold it firmly in mind. Nobody, not even the physicists who study this every day of their working lives, can truly picture a universe smaller than an atom, or particles blinking into existence from pure energy. The mind wasn't built for those scales, the same way it wasn't built to picture a trillion of anything. That's all right, you're not required to picture it clearly. You're only required tonight to rest inside the sound of it. For its first few 100,000 years, the universe was a strange glowing fog, hot, dense, and restless. Hot enough that atoms couldn't yet hold themselves together properly. Electrons zipped around freely, unable to settle into a stable orbit around the nucleus, darting through the crowded universe like sparks in a storm. And that sea of loose charged particles scattered light constantly, bouncing it back and forth from one particle to the next, never letting it travel far in any single direction before being deflected again. If you'd somehow been able to stand somewhere in that early universe, you wouldn't have seen stars, or a horizon, or anything resembling a night sky. You'd have seen a dense, glowing haze in every direction, featureless and blinding. Like standing inside a cloud lit from within by a light with nowhere to go. Slowly, patiently, as the universe kept expanding and cooling, the same steady process that had been unfolding since the very first instant. The temperature finally dropped low enough for something new to happen. Around 380,000 years after the beginning, a heartbeat in cosmic terms, barely a pause when measured against everything still to come. Electrons began settling into orbit around protons, forming the very first complete, stable atoms. Mostly hydrogen, a little helium, the simple, humble beginning of chemistry itself. And the moment that happened, something changed everywhere. All at once, across the entire universe simultaneously. With electrons no longer drifting loose and scattering light at every turn, photons, particles of light, were suddenly free. Free to travel uninterrupted, in straight lines, for the very first time in the universe's short life. The fog lifted. The universe, in a very real sense, became transparent. That first burst of light is still traveling today, all these billions of years later. Scientists call it the cosmic microwave background, and it's one of the most remarkable things we've ever detected. The oldest light in existence, stretched by billions of years of cosmic expansion into faint microwave radiation, arriving from every direction in the sky at once. A fossil imprint of the universe's very earliest moment of clarity. If you've ever seen old analog television static, a small fraction of that flickering noise, a tiny fraction, but a real one, something you could once find simply by turning a dial, is literally the afterglow of the early universe, still reaching us after all this time, unnoticed, woven quietly into the background hum of ordinary life. It's a strange thing to sit with, gently, without needing to fully grasp it. That light left its source before there were galaxies, before there were stars, before there was almost anything at all worth naming. And it's still arriving, quietly, tonight, all around you, all around all of us, all the time, everywhere you might ever stand. After that first light broke free, the universe entered a long, quiet stretch. No stars yet, no galaxies, just that thin, cooling fog of hydrogen and helium, drifting apart in the dark, lit by nothing but the fading glow of its own birth, slowly dimming as the light stretched and weakened with the ever-growing distances between things. Astronomers have a name for this long stretch of time, and it's a fitting one, almost poetic in its simplicity. They call it the cosmic dark ages. It's worth pausing on that phrase for a moment, letting it settle. An entire era of the universe's history, hundreds of millions of years long, defined simply by an absence. No stars, no galaxies, no light of its own being made anywhere. Just a vast, patient darkness, waiting. We'll step into that darkness next, and stay there for a while, the way the universe itself had to. There's no need to rush toward the stars. They'll come, in their own time, the way morning always eventually comes. For now, just rest in that long, patient quiet, a universe cooling slowly in the dark, waiting for its first light to switch on. It's worth imagining just for a moment what it might have felt like to be present for that instant, if there had been anyone there at all to notice it. A universe, suddenly and permanently, becoming visible to itself for the first time. Light finally free to travel, no longer blocked, to reach outward, to eventually, billions of years later, land gently on a telescope mirror built by curious, patient hands. Nobody witnessed it as it happened. And yet, in a very real sense, we're witnessing it still, every time a radio telescope quietly listens to that same ancient glow. For the next 100 million years or so, the universe stayed dark. Not empty, full of hydrogen and helium, drifting quietly through the expanding dark, present everywhere in a thin, patient haze, but dark all the same. No galaxies had taken shape. If you had drifted through that early universe, unseen and unhurried, you'd have found nothing but a faint, cooling haze, stretching in every direction, patient and unremarkable, waiting for something, anything, to happen. But it wasn't truly still. Gravity was already at work, quietly, invisibly, doing the slow, patient job it's been doing ever since. The same job it does today, when a stone falls, or a moon orbits, or an apple, famously, drops from a tree. The early universe wasn't perfectly smooth. Tiny variations in density, laid down in that first instant of inflation, meant some regions of gas were very slightly denser than others. Barely noticeable differences, smaller by far than the wrinkles in a bedsheet. But gravity doesn't need much of a head start. Give it enough time, and even the faintest imbalance becomes something enormous. Over millions of years, those slightly denser pockets of hydrogen and helium began pulling in more material around them, drawing gas inward, ever so slowly, from the surrounding dark. Slowly, patiently, clouds of gas drawing inward, growing denser at their centers, growing warmer as they compressed under their own weight. The same simple process, really, that still forms stars today, unchanged across nearly 14 billion years. Eventually, somewhere in that long, dark stretch of time, one of those collapsing clouds grew dense enough and hot enough at its very center for something remarkable to begin. Hydrogen atoms, crushed together under their own gathering weight, began fusing into helium, releasing in that fusion a tremendous burst of energy, light pouring outward for the first time in the universe's history. A star had switched on. We don't know exactly which cloud it was, or precisely when in that long stretch of darkness. The details are lost to time, the way the first word of any language is lost, unrecorded, unremembered. But these first stars, astronomers call them population 3 stars, were likely enormous, many times the mass of our own sun, burning fast, bright, and short-lived, like a match struck and quickly spent. None of them survive today for us to see directly. But in switching on, they ended the universe's long darkness for good, filling the cosmos, for the first time, with true starlight. A light that would, from that moment on, never entirely go out again. There's something worth sitting with here, gently as you drift, without needing to hold it too tightly. Every atom of light, warmth, and energy that any star has ever produced since, the light reaching your eyes from any star tonight, the warmth of every sunrise there will ever be, the gentle heat of the sun on your skin on some ordinary afternoon you might barely remember. All of it traces back to this same simple process, first switched on in the dark, patient universe, 100 million years after everything began. Those first stars didn't live gentle lives. Massive, unstable, burning through their fuel far faster than smaller, steadier stars do. Many of them likely ended in enormous explosions within just a few million years. Supernovae, scattering the heavier elements they'd forged in their brief, brilliant lives back out into the surrounding gas. Elements like carbon, oxygen, and iron. Elements that hadn't existed at all before those first stars made them, cooked in the furnace of their own dying. This matters more than it might seem. More than a simple fact tucked away in a textbook. Every carbon atom in your body, every bit of oxygen filling your lungs with each slow breath right now, none of it came from the Big Bang itself. Hydrogen and helium, remember, were nearly the entire recipe back then, the only ingredients the early universe had on hand. Almost everything heavier had to be forged inside a star, deep in its burning core, and released back into the universe only when that star died. In a very real, very literal sense, you are made of the ashes of those first ancient stars, assembled, slowly, patiently, across billions of years, into the quiet shape of you. You can let that sit softly in the background as you drift. the way a familiar song settles into the edges of a room. You don't need to hold on to the details, the names, the numbers, just the shape of it, a long darkness, and then slowly, patiently, the first light. And in that light's eventual dying, the first raw material for everything that would ever come after, including, eventually, and quite improbably, you. It's worth noticing, gently, how much of this story so far has depended on patience rather than speed, on small, quiet changes accumulating slowly rather than anything sudden or dramatic. Even the parts that sound violent, a star exploding, a universe stretching faster than light, tend to be brief interruptions in an otherwise slow and steady unfolding. Most of what built the universe you're resting inside tonight happened the way a river carves a canyon, not with force applied all at once, but with the same gentle motion, repeated patiently, for far longer than any single moment could ever account for. Somewhere in a quiet office, right now, on the same small planet we'll return to shortly, there's very likely a researcher awake at their desk, poring over new images from a distant patch of sky, looking for exactly this kind of galaxy, still forming, still finding its shape, billions of light years away. It's a strange, quiet kind of company to imagine. Other curious minds, elsewhere on the same world, turning their attention toward the same vast darkness you're resting inside tonight. As those first stars lived their short, brilliant lives and scattered their ashes back into the surrounding gas, something larger was quietly taking shape around them, out in the wider dark. Gravity, patient as ever, wasn't only pulling gas together into individual stars. It was pulling entire clusters of stars and gas together into much bigger structures, structures that would, eventually, become home to trillions upon trillions of stars each. Picture it slowly, the way it actually happened without rushing. Not a single dramatic moment, but millions upon millions of years of gentle gathering. Clumps of stars merging with other clumps, clouds of gas folding in on themselves, forming bigger, brighter, more intricate shapes, giving birth to whole new generations of stars in the process. Each generation a little richer in heavier elements than the last. Little by little, out of all that drifting material, the first true galaxies began to take form, coalescing slowly out of the darkness, like frost gathering on a cold window. These early galaxies looked nothing like the calm, elegant spirals we associate with galaxies today, the graceful pinwheels you might picture when you close your eyes and imagine a galaxy. They were smaller, more chaotic, clumps and streams of stars still finding their shape, colliding and merging with their neighbors again and again as gravity slowly, patiently organized the young universe into something more ordered. Some astronomers describe this period almost like a long, slow dance of collisions, each merger building something a little larger, a little more structured than what came before it, an unhurried choreography playing out across hundreds of millions of years. The numbers stop meaning very much after a certain point. The way a number like $1 billion or 1,000,000 miles stops feeling like a real, graspable quantity and starts feeling simply like a word for very large indeed. They're not meant to be calculated or held precisely in mind, just felt, softly, as a kind of vastness to rest inside, the way you might rest inside the sound of ocean waves without counting each one. Among all those trillions of galaxies, quietly forming somewhere in that same long stretch of cosmic time, was one that would matter more to our story than all the others combined. Not because it was special in any cosmic sense, not because it stood out among its countless siblings in any measurable way. By most measures, it's a perfectly ordinary galaxy, one among countless others of similar size and shape, unremarkable in the grand catalog of the universe. But it happens to be the one we call home. We'll turn toward it soon. For now, just picture the scene widening, slowly, gently, from a single point in the earliest instant, into a vast and growing scatter of light. Galaxy after galaxy after galaxy, taking shape across an expanding dark, each one a small, quiet fire lit somewhere in an enormous, patient night. If you've ever looked up on a clear night, far from any city, and felt a kind of pleasant smallness settle over you, that feeling has a name among astronomers, though they rarely use it in their papers. They simply feel it too, standing beside their telescopes in the cold and the dark. There's nothing lonely in that smallness, if you let it settle the right way. It's simply the accurate size of things, the true proportion between one quiet, breathing person and the vast, patient galaxy turning slowly overhead. As galaxies grew and settled into their shapes, something else was happening inside them, over and over, in vast, uncountable numbers. Stars. Countless stars forming continuously within the gas clouds that filled these young galaxies, in what astronomers sometimes call the universe's peak era of star formation, roughly 2 to 3 billion years after the beginning. A period when the cosmos was, in a sense, working at its busiest. It's worth slowing down here, gently, because the story of how a star is born is one of the more genuinely beautiful processes in all of nature. And it repeats, quietly, all across the universe to this very day, in some corner of some galaxy, right now, while you rest. It begins with a cloud, vast, cold, mostly hydrogen, drifting through a galaxy, sometimes stretching many, many times wider than our entire solar system, an almost impossibly large and diffuse thing, thinner in places than the best vacuum we can create here on Earth. Left alone, such a cloud might drift for a long time, doing very little, simply existing in its quiet, cold way. But gravity, again, is patient, and it never quite stops working. Some small disturbance, the shock wave from a distant supernova perhaps, rippling outward through the gas, or simply the slow pull of the cloud's own uneven density, is enough to start it collapsing inward, ever so slightly, almost imperceptibly at first. Once that collapse begins, it tends to continue, gathering its own quiet momentum. As the cloud contracts, it fragments into smaller, denser clumps, each one pulling in more material of its own, growing warmer at its center as gravitational energy converts steadily into heat. Slowly, over tens of thousands of years, one of these clumps becomes something new, something almost alive in its slow, steady transformation. A dense, spinning ball of hydrogen gas, glowing dull red with the heat of its own collapse. Astronomers call this a protostar, a star still finding its way toward being a star at all, if it gathers enough mass. And this part matters. This is the threshold that decides everything. If the pressure and temperature at its very center climb high enough, something remarkable ignites. Hydrogen nuclei, crushed together under that immense patient pressure, begin fusing into helium. And in that fusion, an enormous release of energy, light and heat, pouring outward, pushing back against the very gravity that built the star in the first place, until the two forces settle, finally, into a long, stable balance that might last for billions of years. A new star has switched on, and around it, often, spinning in the same flattened disk of gas and dust the star itself formed from, smaller clumps of material may be gathering too, quietly, patiently. The first humble beginnings of planets, waiting in orbit around their new sun, not yet worlds, but no longer simply dust either. This same quiet process, cloud collapse, protostar ignition, has repeated an almost uncountable number of times across cosmic history, in every galaxy, in every era, without pause. Every star you might picture tonight, every point of light in every night sky that has ever existed, began this same way. A cold cloud, drawn slowly inward by its own gravity, until something at its center finally caught light, the way a single spark, given enough kindling and enough patience, eventually becomes a fire. Not every star is the same, of course, and their differences shape entirely different fates. Some, far more massive than our own sun, burn hot and fast, living only a few million years. A blink, cosmically speaking, before ending in dramatic supernova explosions, scattering, as we heard earlier, the heavier elements they forged back out into space to seed the next generation of stars and planets. Others, smaller and cooler than the sun, burn so slowly and so efficiently that some of the very first stars of this kind, formed billions of years ago, in that same long-ago era, are likely still quietly burning today, and will continue to do so for trillions of years yet to come, far longer than the universe itself has even existed so far, patient beyond any human sense of the word. There's a kind of gentle rhythm to it, if you let yourself feel it, rather than think it through logically. The way you might feel the rhythm of your own breathing without needing to count each breath. Stars are born, live out their lives, some brief and violent, some slow and patient, stretching across timescales beyond easy comprehension. And in dying, many of them scatter the raw material for the next generation. Gas becomes star, becomes ash, becomes eventually new gas, new stars, new possibility. A long, unhurried cycle, repeating quietly across billions of years, indifferent to anything except the simple pull of gravity and the patient, steady burn of fusion. Somewhere in the midst of all this vast, ongoing activity, one star, among the hundreds of billions being born across one particular galaxy, in one particular era of this vast unfolding story. A cloud of gas was beginning, very slowly, to collapse. Nothing marked it as special, nothing set it apart from countless similar clouds scattered across that same galaxy. We'll turn to that one specifically before long. For now, just let the picture rest there. Soft and wide. Countless small fires switching on quietly across a darkening universe. Each one beginning the same slow, patient way, indifferent to time, indifferent to everything except the simple, ancient pull of gravity. Even now, astronomers are still mapping this process in detail, pointing enormous telescopes toward distant, young galaxies still caught in the act of forming, still colliding, still finding their shape, sending back light that left its source when the universe itself was only a small fraction of its current age. In a strange way, looking far enough into space is the closest thing we have to time travel, a chance to watch the universe's own childhood unfolding, frozen in light, still arriving after all this time. The Milky Way has a rough, gentle nickname among some astronomers, drawn simply from how it looks from Earth on a truly dark night. A soft, pale band of light stretched across the sky, made up, in truth, of countless individual stars, too faint and too numerous to pick apart with the naked eye. Ancient civilizations gave that pale band their own names too: rivers of milk, paths of straw, roads walked by ancestors. It's the same galaxy in every story, seen from the same small vantage point, described 100 different gentle ways. Let's narrow our view now, gently, from trillions of galaxies scattered across an unimaginable darkness, down to just one. The one we happen quite by chance to call home. The Milky Way likely began taking shape in a way similar to the galaxies we've already described. Smaller clumps of stars and gas, drawn together by gravity, merging and growing over billions of years into something larger, more organized, more settled. Some of the oldest stars we can still observe in our galaxy today are thought to be over 13 billion years old, ancient beyond easy comprehension, meaning they formed when the universe itself was still remarkably young. Not long, in cosmic terms, after those very first stars switched on in the dark. Some of that light, in a sense, is older than almost everything else in this story so far. Slowly, over these enormous stretches of time, the Milky Way settled into the shape astronomers now recognize and have carefully mapped. A great spinning disk, marked by sweeping spiral arms curving gently outward, with a dense, bright bulge of older stars gathered at its center. At the very heart of that bulge sits something almost impossible to picture calmly. Something that sounds on the surface almost frightening, but really isn't. A supermassive black hole, with a mass equivalent to roughly 4 million suns, quietly anchoring the gravity of the entire galaxy around it. The same way a single stone at the center of a whirlpool holds the whole pattern together. The way it's sometimes dramatized in films and stories. Most of the time, it sits there quietly, almost sleepily. Its enormous gravity simply helping to hold the galaxy's shape together, largely undisturbed, doing very little from one century to the next. Our galaxy is enormous by any human measure, in a way that resists easy comparison. Roughly 100,000 light-years across, meaning light itself, the fastest thing in existence, the thing that crosses the vast gap between the sun and Earth in a mere 8 minutes, takes 100,000 years just to cross from one edge of our galaxy to the other. And within that vast spinning disk, scattered across its sweeping arms like grains of sand across an enormous beach, sits somewhere between 100 and 400 billion stars, each one its own small fire, each one, quite possibly, warming worlds of its own. You don't need to hold that number precisely, or do anything with it at all. Just let the shape of it settle, softly, the way a large, unfamiliar word settles into memory, without needing to be defined. An almost uncountable scatter of stars, slowly wheeling together through space, bound by gravity into one enormous, patient structure, turning as it has turned for billions of years, and will keep turning for billions more. The Milky Way itself isn't standing still, of course. Nothing in this story ever really is. Nothing ever has been, not since that very first instant of expansion. It's drifting through the wider universe, slowly rotating on its own vast axis, and it has spent billions of years quietly merging with smaller neighboring galaxies, absorbing them one by one over unimaginable stretches of time, growing larger with each gentle, gradual encounter. Some of the stars scattered through our galaxy tonight, some of the very stars that might be visible above you if the clouds cleared and the lights went out, may have originally belonged to entirely different galaxies altogether, long ago folded into our own through these slow, ancient, almost invisible collisions. Somewhere out along one of the Milky Way's spiral arms, not near the crowded, chaotic center, where stars are packed close and radiation runs high, but in a quieter, more ordinary stretch of the galaxy, roughly halfway out from the middle, in what you might almost think of as the suburbs of the galaxy. A cloud of gas was drifting, unremarkable by galactic standards, in every conceivable way. One of countless such clouds scattered throughout the disk, drifting slowly, patiently, doing very little of note. But that particular cloud, roughly 4.5 billion years ago, was about to begin collapsing. We'll follow it closely now, gently, the way you might follow a single thread pulled loose from a much larger tapestry. This is where our story starts to feel less abstract, less vast and impersonal, and more, at last, like home. There's something worth noticing, softly, in how ordinary our galaxy's story turns out to be, once you sit with it for a while. Nothing about the Milky Way's formation set it apart from countless other galaxies scattered across the observable universe. No unusual ingredient, no rare event, nothing that marks it as special among its trillion or so siblings. And yet, of all those trillion galaxies, this happens to be the one holding the story we're following tonight. The one quiet corner of an unimaginably vast cosmos that happens this evening to matter most. Picture that cloud, drifting quietly through the outer reaches of the Milky Way, unremarkable and unhurried. Mostly hydrogen and helium, the same basic ingredients present since the earliest minutes of the universe, largely unchanged across billions of years, but also, scattered through it, small traces of heavier elements. Carbon, oxygen, iron, and more, seeded into this cloud by generations of earlier stars that had lived and died long before, scattering their ashes across this same quiet stretch of the galaxy, layer upon layer, generation upon generation, like sediment settling slowly at the bottom of a lake. Something, perhaps the shock wave of a nearby supernova, rippling outward through the gas, perhaps simply the slow pull of the cloud's own uneven density, some small imbalance that had been waiting patiently to matter, disturbed that quiet equilibrium, and the cloud began very slowly to collapse inward under its own weight. As it contracted, it began to spin faster, the same way a skater spinning slowly draws their arms in close and speeds up, conserving the same rotation across a smaller space. And as it spun, it gradually flattened, the way pizza dough spreads and flattens when tossed and spun through the air, into a wide, swirling disk, with the greatest concentration of material gathering densely at the very center, drawn inward by its own accumulating gravity. At that center, over roughly 100,000 years, a mere flicker of time by the standards of everything we've discussed tonight, pressure and temperature climbed and climbed, higher and higher, until finally hydrogen began fusing into helium. A star had ignited, quietly, in an unremarkable corner of an unremarkable galaxy. Our sun. It's a strange, quiet thing to picture, if you let yourself sit with it for just a moment. The same sun that will rise again tomorrow morning, gentle and familiar, that has warmed every single day of your entire life, every summer afternoon and every cold winter morning, beginning as an ordinary clump within an ordinary drifting cloud, in an unremarkable stretch of an unremarkable galaxy, among trillions of others just like it. Nothing about its birth was special. Nothing marked it out for any particular fate. And yet here we are, resting somewhere warm, tracing the story all the way back to that quiet, unremarkable beginning. Around that newborn sun, the leftover material in the flattened disk, dust, ice, small rocky fragments, the crumbs left over from the sun's own formation, began doing what matter tends to do, patiently, when given enough time and enough gravity to work with. Colliding, sticking together. Small grains became pebbles, pebbles became boulders. Boulders over millions of quiet years became larger bodies still, sweeping up material as they orbited, growing steadily larger through countless slow, gentle collisions, each one adding just a little more mass than the last. Astronomers call these growing bodies planetesimals, and eventually, protoplanets, the early, still-forming versions of the planets we know today, worlds still finding their final shape. Closer to the young sun, where temperatures were too high for ice to survive the heat, only rock and metal could condense out of the swirling disk, giving rise to the smaller, denser worlds we now call the inner planets: Mercury, Venus, Earth, and Mars, each one built from much the same raw material, in much the same corner of the young solar system. Beyond a boundary, astronomers sometimes call the frost line, ice could survive alongside rock and metal, allowing much larger bodies to form, bodies massive enough to hold on to far more material. The gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune, massive enough eventually to pull in thick atmospheres of hydrogen and helium directly from the surrounding disk before it dispersed entirely. This entire process, from a quietly collapsing cloud to a young sun surrounded by a full family of forming planets, likely took somewhere in the range of 10 to 100 million years. A vast stretch of time by any ordinary human measure, longer than our own species has existed by a wide margin. And yet, in cosmic terms, really quite fast. A brief, busy chapter tucked into an otherwise slow and unhurried story. By roughly 4.5 billion years ago, the basic shape of our solar system had settled into something recognizable. Something not so different from the arrangement we know today. A bright young star at the center, still finding its rhythm. And around it, in wide, patient orbits, the beginnings of 8 planets, along with countless smaller bodies, moons still forming, asteroids drifting between the larger worlds, and icy fragments left over from everything that hadn't quite made it into a planet at all, scattered across the outer reaches, like unused pieces from some enormous, patient construction project. One of those forming worlds, the third from the sun, still glowing hot from the violence of its own formation, still far from anything resembling the world you know, was Earth. We'll spend some time there next, gently, the way we've spent time everywhere else in this story so far. For now, just let the picture settle quietly, softly, behind your closed eyes. A young sun, newly lit, surrounded by a slowly cooling family of worlds, still finding their final shapes, still settling, still becoming whatever they were going to become. It's a strange kind of luck, if you can call it luck at all, that this particular story, out of every possible story the universe might have told, happened to unfold in exactly the way it did. A slightly different disturbance in that ancient cloud, a slightly different amount of material gathered at the center, and the sun that formed might have burned differently entirely, hotter or cooler, brighter or dimmer, its family of planets arranged in some other pattern altogether. None of that happened. This happened. And here you are resting somewhere warm, at the far end of that one particular, unrepeatable chain of events. Even today, scientists can trace faint chemical fingerprints in very old rocks, tiny clues pointing back toward Earth's molten, restless childhood, evidence patiently gathered from mountainsides and ocean floors, and meteorites that fell from that same ancient, chaotic solar system. Every rock beneath your feet, if you trace it back far enough, carries some quiet trace of that early violence, softened now, worn smooth by billions of years of patient, uneventful time. In its earliest days, Earth looked nothing at all like the world you know, nothing like the quiet, blue, familiar planet you might picture when you close your eyes and think of home. No oceans yet, no soft green anywhere. Just a molten, glowing sphere, its surface an ocean of liquid rock, bombarded constantly by the leftover debris, still drifting through the young, chaotic solar system. Smaller planetesimals, asteroids, chunks of rock and ice, crashing into the forming planet again and again, as it swept up the last remaining materials scattered along its orbital path. One of those collisions, roughly 4.5 billion years ago, was almost unimaginably violent. A moment of chaos so large, it's still shaping our nights today. A Mars-sized body, sometimes given the name Theia, is thought to have struck the young Earth in a glancing blow, a collision of a scale almost impossible to picture calmly. The impact would have been catastrophic beyond easy description, melting and vaporizing enormous amounts of rock, throwing a vast cloud of debris into orbit around our battered, reeling planet. Slowly, over time, that debris gathered itself together under its own gravity, cooling and consolidating into a single, smaller companion world, orbiting quietly alongside the planet that had, in a sense, given birth to it. Our moon. It's a gentle thought to rest on, if you'd like to, letting it settle softly somewhere behind your eyes. The moon you might glimpse through your window tonight, calm and silver and utterly familiar, was born out of a violence almost too large to picture, a collision that reshaped an entire planet. And yet, over billions of years since, it settled into something quiet and steady, its gravity gently stabilizing Earth's tilt, keeping our seasons mild and predictable, rather than wild and chaotic. Its slow, patient pull, shaping the rhythm of ocean tides, faithfully circling our planet every 27 days, exactly as it has since not long after Earth itself was formed. A quiet companion for nearly the whole of our planet's long history. As Earth continued cooling over its first several 100 million years, heavier elements, iron especially, sank slowly toward the center under their own weight, forming a dense metallic core, while lighter rocky material rose toward the surface, forming the mantle and eventually a thin solid crust, the first hint of solid ground anywhere on this glowing, restless young world. Volcanic activity, immense and near constant in these early years, released gases from deep within the planet. Water vapor, carbon dioxide, nitrogen, slowly forming Earth's first true atmosphere. Thin and strange by today's standards, but an atmosphere nonetheless. And as the planet continued to cool, slowly, patiently, that water vapor began to condense out of the thickening air. Rain falling perhaps for the first time in Earth's history, in storms unlike anything that has happened since, fell for what may have been millions of years, gradually filling the low-lying basins of the young planet's surface, drop by drop, year by year, century by century. The first oceans. Meanwhile, close by in that same young solar system, two other worlds were following very different paths, shaped by nothing more than their distance from the sun and a handful of small differences in their early history. Venus, similar in size to Earth and formed from much the same raw material, so nearly a twin in almost every respect, ended up trapped by a runaway greenhouse effect. Its thick atmosphere of carbon dioxide, holding in heat so effectively that its surface today reaches temperatures hot enough to melt lead, hotter even than Mercury, despite being much further from the sun's warmth. Mars, smaller and further out, cooled more quickly than its larger neighbors. Evidence strongly suggests it once had liquid water on its surface, rivers and lakes, and perhaps even shallow seas, along with a thicker atmosphere than it has today. A world once far more hospitable than the cold, dry place we see now. But, without Earth's protective magnetic field, generated by the slow, steady churn of its molten core, solar radiation gradually stripped much of that atmosphere away over billions of patient years, leaving behind the cold, thin, rust-colored world we observe today, its ancient rivers long since dried to nothing but faint traces in the rock. Three worlds, formed from strikingly similar raw material, in roughly similar corners of the same young solar system, born within a few million years of one another, and yet three entirely different fates, three entirely different stories. Earth alone settled into the narrow, gentle balance that allowed liquid water to persist on its surface for billions of years since, an extraordinarily fine margin between too hot and too cold, too thick an atmosphere and too thin. It's worth resting on that quietly for a moment, without worry, without needing to feel anything sharp about it at all. Just a soft kind of attention, the way you might notice a particularly gentle afternoon light without needing to comment on it. Of everything that could have gone differently, in 100 small and enormous ways, across billions of years of chance and circumstance, this particular world, spinning gently through the dark, found its way to something rare enough to hold oceans and skies, and eventually, quietly, improbably, you. Scientists still study Theia's impact today, piecing together its story from clues left behind in moon rocks brought back by astronauts, careful chemical traces that quietly confirm just how violent and how formative that single ancient collision truly was. It's strange to think that some of the calm you might feel looking up at a full moon traces back to an event so catastrophic it briefly turned part of the young Earth's surface to glowing liquid rock. Violence, given enough time, has a way of settling into something gentle. It's worth noting, gently, how differently each of these outer worlds turned out, despite forming from the same swirling disk of material, around the very same star, at very nearly the same time. Distance from the sun, size, the particular timing of a stray collision, small differences compounding slowly over billions of years into entirely different worlds, one wrapped in colorful bands of storm, one ringed in ice, one tipped over on its side entirely. There's a quiet lesson in that, if you'd like to take one, though you don't have to. Small differences given enough time tend to become very large ones. Further out from the sun, beyond Mars and the wide scattered belt of rocky debris that never quite gathered itself into a planet of its own, the solar system takes on an entirely different character, colder, larger, stranger. Jupiter, first among the outer worlds, is by far the largest planet in our solar system, so massive that all the other planets combined, every single one of them, added together, could fit inside it more than once over, with plenty of room still to spare. It has no solid surface to speak of, at least not one we could ever hope to stand on. Its swirling, banded atmosphere of hydrogen and helium simply grows denser and denser, with depth, layer upon layer, eventually compressing into something closer to a liquid. Then finally, deep within, into a strange and still poorly understood core, hidden beneath thousands of miles of crushing pressure. Jupiter's great red spot, a colossal storm, wide enough to swallow Earth several times over, with room left besides, has been raging on its surface for at least a few hundred years, quite possibly far longer than that, possibly for as long as anyone has been watching it through a telescope. It's a strange thing to picture, gently, without alarm, a single storm outliving every human civilization that has ever watched it, spinning quietly on, indifferent to the passage of empires below. Circling Jupiter are dozens upon dozens of moons, an entire small solar system of its own, but a handful of them deserve particular mention, gently, as we drift slowly past. Europa, its icy surface hiding what many scientists believe is a vast, liquid ocean beneath, kept warm by the same gravitational forces that squeeze and flex the moon as it orbits. An ocean that may, just possibly, hold conditions suitable for some very simple form of life, though we don't yet know for certain, and may not for a long while yet. Io, the most volcanically active body anywhere in the solar system, its surface constantly reshaped by eruptions driven by the immense gravitational strain of orbiting so close to giant Jupiter. A small, restless world in a state of near constant transformation. Further out still, Saturn, perhaps the most immediately beautiful of all the planets, the one that tends to draw a quiet gasp the first time anyone sees it properly through a telescope, ringed by a wide, glittering system of ice and rock particles, some as small as grains of dust, others as large as houses, all held in place by the delicate, patient balance of orbital mechanics. A vast, thin disk of debris circling endlessly, never quite settling into a single moon. Among Saturn's many moons, Titan stands out in particular, the only moon in the solar system with a substantial atmosphere of its own, thick and hazy, and remarkably, lakes and rivers on its surface, though filled not with water, but with liquid methane and ethane, in the deep, patient cold of the outer solar system. A strange, foggy world, unlike anywhere else we know. Beyond Saturn drift the two ice giants, Uranus and Neptune, distant and cold, their pale blue-green color coming from methane in their atmospheres, which quietly absorbs red light and reflects blue back toward us across billions of miles of empty space. Uranus strangely spins almost completely on its side, tilted at an angle unlike any other planet, likely the result of an ancient, enormous collision sometime in its early history. A reminder that even now, billions of years later, we're still reading the scars of violent events from the solar system's early chaotic youth, written quietly into the tilt of a distant icy world. And far beyond Neptune, scattered thinly across the outer darkness, drift countless smaller icy worlds, Pluto among them. Along with a great many others, remnants of the solar system's original formation that never gathered into anything larger, small, cold, and largely forgotten, drifting slowly through the outer dark on orbits that take centuries to complete. You don't need to hold every detail of this in mind, none of the names or the numbers. Just let the picture widen gently, the way a room seems to widen as your eyes adjust to darkness. Our small, warm, blue world, and around it, further and further out, an entire family of neighboring worlds, each one shaped by its own particular history, its own particular distance from the sun, its own particular fate. There's a particular stretch of Earth's story worth lingering on a moment longer, gently, before we move past it. For roughly the first 2 billion years of the planet's existence, nothing alive had eyes, or limbs, or any way of moving with purpose at all. Just simple cells, drifting, dividing, quietly surviving in warm, shallow water, generation after generation, for a length of time longer than the entire span from the first dinosaur to right now, repeated many times over. It's tempting to think of that stretch as empty or wasted, waiting for something more interesting to happen. But nothing about it was wasted. Every one of those billions of years was doing exactly what it needed to do, laying down, slowly, patiently, the chemistry that everything more complex would eventually depend on. Back on Earth, sometime in that first billion years after the planet formed, while the rest of the solar system settled slowly into its familiar shape, something happened that, as far as we can tell, may be genuinely rare across the wider universe. Rare enough that we've never yet found clear evidence of it happening anywhere else. Life began. We don't know exactly how, not with the kind of certainty that lets a story be told cleanly from start to finish. It remains one of the great open questions in all of science, one of the last true mysteries at the very center of biology. How simple, non-living chemistry, given enough time and the right conditions, first organized itself into something capable of reproducing, of responding to its environment, of what we'd recognize, even in its simplest form, as being alive. Perhaps it began in shallow tidal pools, warmed gently by sunlight, chemicals concentrating slowly as water evaporated and returned. Perhaps deep in the ocean, near hydrothermal vents, where mineral-rich water, heated by the planet's own inner warmth, seeped up through cracks in the seafloor, carrying with it exactly the right ingredients in exactly the right conditions. We simply don't know for certain yet, and perhaps we never fully will. What we do know is that it happened remarkably early, almost as soon as the planet allowed for it at all. Some of the oldest evidence for life on Earth dates back roughly 3.5 to 4 billion years, meaning life may have begun taking hold on this planet almost as soon as conditions allowed for it at all. Geologically speaking, barely a pause after Earth's surface had cooled enough to hold liquid water in the first place. For an enormously long stretch of time, after that first spark, well over 1 billion years, and by some estimates closer to 2, life on Earth remained simple, humble, unremarkable to any outside observer. Single-celled organisms, drifting quietly through ancient oceans, far too small to see without help, going about their slow, patient business, unnoticed and unhurried. No plants, no animals, no visible life at all. If you'd been able to stand on an early Earth shoreline and look out across the water, nothing but waves and wind and a strange empty quiet. But somewhere in the midst of that vast stretch of quiet, single-celled life, something else happened that would eventually make everything else possible. A small, quiet breakthrough with enormous consequences. Certain microorganisms developed the ability to harness sunlight directly, converting it, along with water and carbon dioxide, into energy. A process we now call photosynthesis. The same basic trick every green leaf still uses today. And as a byproduct of that process, these tiny organisms began releasing oxygen into Earth's atmosphere. Slowly, patiently, breath by microscopic breath. Slowly, over enormous stretches of time, hundreds of millions of years, that oxygen accumulated, reshaping the planet's atmosphere entirely, rusting iron in the rocks, changing the very color and chemistry of the world, and eventually making possible the kind of complex, oxygen-breathing life that would follow much, much later, including, eventually, the slow, steady breaths you're taking right now. From there, the story continues slowly unfolding across truly vast stretches of geological time, each chapter longer than the last, each one building quietly on everything that came before. The first complex multicellular organisms, roughly 600 million years ago. Simple bodies made of more than one kind of cell, working together. The first creatures with hard shells and skeletons. Not long after, the first hints of something like a body plan. Life gradually moving from ocean to land, tentative and slow. Plants spreading green across a once barren shoreline. Insects filling the air for the first time. The rise and fall of the dinosaurs, ruling the planet for well over 100 million years, longer by far than our own species has yet managed, before their sudden, catastrophic end. And eventually, following an unbroken chain stretching back across nearly the entire history of life on Earth, small mammals, then primates, then very recently indeed, in this enormous story, barely a heartbeat ago in cosmic terms, something recognizably, quietly like us. We won't walk through all of that tonight, gently setting it aside for now. That's a story vast enough to fill an evening of its own, perhaps a night we'll spend together another time. For now, it's enough just to hold the shape of it loosely, without grasping too tightly. A lifeless world, and then, quietly, almost unnoticed, the first spark of something alive. And from that first spark, across billions of patient years, everything that followed, layer upon layer, one small step after another, until eventually, you. There's a quiet symmetry in it, if you let yourself notice it softly. Life on Earth needed billions of years of patient, uneventful stability to take hold and slowly grow more complex. The same kind of patience the universe itself has shown at every stage of this story. Nothing about tonight's story has ever been in a hurry. Stars take millions of years to form, galaxies take billions to settle into shape. And somewhere in the middle of all that vast, unhurried patience, life simply had the time it needed, and used it. There's a particular kind of research that speaks to this question directly, gently, worth mentioning before we widen our view further. Astronomers have now confirmed thousands of planets orbiting other stars. Worlds we call exoplanets, some rocky, some gaseous, some sitting in what scientists call the habitable zone, that narrow, gentle band of distance from a star, where liquid water could plausibly exist on a surface. None of them have yet shown any clear sign of life. But the search continues, patiently, telescope by telescope, star by star, driven by the same quiet question that's been threaded through this whole story tonight. Whether this small, warm, blue world was a rare and lucky exception, or simply the first of many stories like it, still waiting, somewhere out in that vast dark, to be found. Let's step back now, gently, from this one small planet and its long, patient story of life, and take in the wider view of the universe as it stands today, roughly 13.8 billion years after that very first instant we began with tonight. The universe is still expanding. It never stopped, not once, across this entire story we've been tracing tonight, not for a single moment since that first instant of inflation. And strangely, based on decades of careful, patient observation, it isn't just expanding, it's expanding faster now than it was billions of years ago, the rate of stretching quietly increasing, rather than slowing down, as you might expect. Something is pushing galaxies apart at an accelerating rate, and scientists have given that mysterious something a name: dark energy, without yet fully understanding what it actually is, or why it behaves the way it does. It's thought to make up roughly 70% of all the energy and matter in the universe, and yet it remains one of the deepest, most stubborn unsolved mysteries in all of science, hiding in plain sight across the entire cosmos. Alongside dark energy, there's dark matter too, which we touched on earlier, that unseen scaffolding that helped shape galaxies in the universe's early youth, still quietly present today, still doing its invisible work. Together, dark matter and dark energy make up around 95% of everything that exists, everywhere, in the whole vast universe. Which means all of it, every star, every planet, every galaxy we can actually see and study directly with our telescopes, is a small fraction of the whole picture. A thin surface layer over something far larger and far stranger. A quiet reminder that even after everything we've learned, everything we've carefully measured and mapped, most of the universe remains, gently, patiently, a mystery. The observable universe today stretches roughly 93 billion light-years across, an almost meaningless number by any ordinary human measure. Though it's worth remembering, softly, that observable is the key word there. Because the universe has been expanding for its entire existence, and light, however fast, can only travel so quickly. There's almost certainly more universe beyond what we can ever observe, stretching outward further than we'll ever be able to see, no matter how advanced our telescopes become, no matter how patiently we search. Within that observable portion scattered across the dark, sit those 1 to 2 trillion galaxies we mentioned earlier, each one home, on average, to hundreds of billions of stars, each one its own quiet island of light in an otherwise dark and silent ocean. Our own Milky Way is just one among them, unremarkable in most respects, quietly turning through space alongside its neighbors, as it has for over 13 billion years, and will likely continue to do for billions more. We've learned an extraordinary amount about all of this in a remarkably short time, a blink of an eye set against the vast story we've spent tonight tracing. It was less than a century ago that Edwin Hubble first noticed the universe was expanding at all, a discovery that would once have seemed like something from an entirely different kind of story. In the decades since, we've mapped the afterglow of the Big Bang itself, detected ripples in space-time from colliding black holes billions of light-years away, faint tremors passing quietly through the fabric of space, and quite recently, sent a telescope, the James Webb, far enough into space to capture light from some of the very first galaxies ever to form. Light that's been traveling toward us for over 13 billion years, only now arriving, only now being seen, for the very first time, by anyone, anywhere. It's a strange privilege in a way, worth resting on quietly, for just a moment. To exist at this particular moment, in this particular story. A species young enough to still be discovering the shape of its own universe, but old enough, finally, patiently, to have built the tools capable of looking back almost all the way to the beginning. You don't need to hold on to any of these numbers precisely, not one of them. Just let the picture rest there, wide and quiet, behind your closed eyes. An almost incomprehensibly vast universe, still expanding, still largely mysterious, and somewhere within it, one small, warm blue planet, quietly turning, carrying you. It's worth sitting, just briefly, with how young our understanding of all this really is, set against the age of the universe itself. Every telescope we've ever built, every equation, every careful measurement, belongs to the last 100 years or so of a story nearly 14 billion years long. A sliver of time so thin it barely registers against everything we've covered tonight. And yet in that sliver, we've managed to trace the outline of almost the entire story, back nearly to the very beginning. There's something quietly remarkable in that, worth resting on gently before we turn toward what's still to come. None of what we're about to describe should feel like sad news, carried into your evening. 5 billion years is a span of time so far beyond any human concern that it barely qualifies as the future at all. In any meaningful sense, not backward through everything that's already happened, but forward, softly, into everything still to come. Across stretches of time, even longer than everything we've covered so far tonight. Our own sun, roughly halfway through its life, will continue burning steadily for billions of years yet. There's no need to hold any urgency about this at all. None whatsoever. It's simply part of the shape of things, as ordinary and unremarkable, in its own way, as the turning of a season. But, eventually, in around 5 billion years, having exhausted the hydrogen fuel at its core, after all this time, the sun will begin to swell, cooling and reddening as it expands into what astronomers call a red giant, likely growing large enough to engulf Mercury and Venus, and possibly, though this part remains uncertain even to careful scientists, the orbit of Earth itself. After that swollen phase, the sun will gently shed its outer layers into space, drifting outward in slow, glowing clouds, forming a brief, beautiful structure called a planetary nebula, before settling into its final, quiet form, a small, dense, slowly cooling ember called a white dwarf, which will go on glowing faintly, doing very little, for trillions of years, into the deep, patient future, long after everything else in this story has faded. Long before any of that, though, something else will happen, something almost impossible to feel afraid of, given how distant and slow it truly unfolds. Our own Milky Way galaxy is slowly, patiently drifting toward our nearest large galactic neighbor, Andromeda, and in roughly 4 to 5 billion years, the two galaxies will begin to merge, drawing closer across an unimaginable stretch of space and time. It sounds on the surface like a catastrophe, two vast galaxies colliding head-on. In practice, galaxies are so vast and stars within them so widely spaced that a galactic merger is remarkably gentle at the level of any individual star. The chance of any two stars actually colliding almost vanishingly small, smaller than you might think possible for something so enormous. Over a few billion more years, the two galaxies will simply settle together into a single larger galaxy, sometimes given the nickname Milkomeda. Its shape gradually reorganizing itself into something new, something neither galaxy quite resembled on its own. Zooming out much further still, into timescales that stop feeling entirely real, that stretch past anything a human mind comfortably holds, trillions of years from now, long after our sun has faded into its quiet ember, star formation across the universe will slowly wind down, as the raw material for new stars is gradually used up and not replaced, cloud by cloud, galaxy by galaxy. One by one, the stars that remain will burn out, their long lives finally ending. Some will fade quietly into white dwarfs. Some will end in supernova, leaving behind neutron stars or black holes, dense remnants of what once was. Given enough time, an amount of time almost impossible to picture, let alone say out loud, the universe may eventually settle into a long, cold, mostly empty darkness, sometimes called the heat death of the universe, where energy has spread so thin and so evenly across space that almost nothing meaningful happens anymore, ever again. A vast, quiet stillness, stretching on forever. It's a strange thing to hold, this ending, if you can even call it that at all. It's so distant, so slow, so utterly beyond any human timescale, that there's really nothing to fear in it. Nothing more, perhaps, than there is to fear in the fact that today will eventually become tomorrow, and tomorrow, the day after that. It's simply the shape the story takes, over a truly enormous stretch of time, longer than anything we could ever hope to witness or measure. And there's something quietly comforting, too, in knowing that we happen to exist in this particular moment. This narrow, fortunate sliver of cosmic time. A universe still young enough, still active enough, still full enough of starlight and warm planets, and apparently curious, sleepy creatures like yourself, lying somewhere safe and warm, listening to the whole vast story unfold, one quiet word at a time. None of this needs to feel heavy, even the parts that stretch toward endings. A universe this large, this patient, has room enough for both a beginning and an eventual quiet close, and neither one asks anything of you tonight, except perhaps a little perspective, a little softness toward whatever ordinary worries followed you into bed this evening. They're small against all this. They were always small. That was always allowed to be a comfort, not a judgment. If you're still listening at this point, still resting somewhere quiet, know that most people who begin this particular story don't make it all the way to the end awake. And that was always exactly right. The story doesn't mind being missed. It was never really about reaching an ending. It was always simply about the slow, patient act of moving through something vast together, one gentle sentence at a time, until eventually, softly, that vastness became easier to rest inside than to stay awake and think about. So that's the story, or at least the shape of it. From a single point, smaller than anything imaginable, through the first stretching of space itself, through darkness and the first patient light of the earliest stars, through galaxies gathering slowly out of the dark, through one particular star switching on along one particular spiral arm, through small worlds cooling and settling into their final shapes, through one especially fortunate blue planet finding its way, against considerable odds, across billions of quiet years, to oceans and skies, and eventually, quietly, to life. And now, somewhere near the very end of that impossibly long story, here you are, lying still, breathing slowly, made in the most literal sense, from the scattered ashes of stars that lived and died long before the sun even existed, before the earth had a name, before there was anyone at all to give it one. There's nothing you need to do with any of this, none of it at all. No part of tonight's story requires anything of you, except simply to rest. The universe will go on unfolding slowly, patiently, exactly as it always has, whether you're awake to think about it or not, whether anyone is watching at all. The stars above you tonight, if you can see them through the ceiling, through the clouds, are still burning, exactly as they have been, exactly as they will keep on being long after tonight is over. Tomorrow the sun will rise, gently, over this small, warm, impossibly fortunate world, just as it has every single day of your life, and every day for billions of years before you ever arrive to see it. You don't need to hold on to anything from tonight, not the numbers, not the names, not the long, careful chain of events that led, somehow, improbably, patiently, to you. Just the soft, wide feeling of it all. A vast, quiet universe, unfolding slowly around you. And within that vastness, this one small, safe moment, right now, where all you need to do, gently, finally, is let go and rest.